Hello. Today we're going to talk about 4.7, the quadratic formula. So maybe you remember this from Algebra 1. Hopefully you do. Usually it's associated with a song. I'll leave you to look up that on YouTube just because I know I'm not going to do it justice, okay? All right. So it's in the tune of Farajaka. So it's negative b plus or minus square root of b squared minus 4ac all over 2a. So what you do here is you will plug in the coefficients. So you have a, b, and c. It's always in this order. You cannot put a with x and c with x squared. You can't do that. Okay, so it has to be in that order. You just plug in the coefficients into this equation and pop comes the solutions. Okay, so you think it would be easy, but I see kids mess this one up all the time because they plugged it in correctly. Okay, so let's see. Let's start with number 1. So again, you want to line it up with, let's write it this way, ax squared plus bx plus c always equals 0. So in this situation, we have a equals 1, b equals negative 4, and c equals negative 5. So in our equation, we have negative b. The first thing I do is I write everything with parentheses around each variable. Okay? So we have plus or minus, and then we have b squared minus 4ac all over 2a. And then I go and substitute things in. So we can replace the a here with a 1. Okay, then we can replace the b right here with negative 4, and our c with negative 5. Okay, so that's how you want to write it. Now we can start simplifying. The negative 4 becomes a positive 4 plus or minus. Negative 4 squared is 16. Negative 4 times 1 times negative 5 is positive 20 all over 2. So we get 4 plus or minus the square root of 36 all over 2. 4 plus or minus 6 all over 2. I get a lot of kids that want to stop there. Okay? This is when I know that you know what this plus or minus means. Okay? That's just the lazy mathematician's way of writing their answer. Okay? Because we just don't want to write it twice. But if you think about this, these are all nice numbers. I can combine all of these numbers. So I should split it. The only reason I would leave it like this is if I had a square root. Okay? So if I've got nice whole numbers, then split it. So we're going to have 4 plus 6 over 2 and 4 minus 6 over 2. So then we get 10 over 2, so we get 5. Here we get negative 2 over 2. We get negative 1. So our answer is 5 and negative 1. Okay, do not write it like this. Make sure you split it. Okay, this makes more sense. This is just lazy. Okay, all right. So let's do another one. So let's try this one. We have negative b squared minus 4ac all over 2a. We get 2. 4 minus 20 all over 2. Then we get 2 plus or minus the square root of negative 16. All right, well, we can simplify that radical and get 4i all over 2. All right, again, standard writing, we usually write it as a plus bi. Right, so notice we don't have a whole fraction, so we split this and we divide each part. So this term over the denominator, separated by the addition and subtraction. The next term over that number. So here our answer would be 1 plus or minus 2i. Okay? All right, so that's how we would simplify our fraction. All right, you need to know how to do this. The quadratic formula works for every single problem. Okay? We know that factoring works, but not for every problem, right? We can't factor this one. This is considered prime if I asked you to factor it. However, I can still solve it by either completing the square or using the quadratic formula. Both of those will work every single time. However, you can, most kids or most people tend to avoid completing the square when there's an a value. If you have an a value, typically that's when you get your fractions. Okay? But the quadratic formula, this works every single time. I've known a lot of kids that like to just stick to this and just run with it. Okay? But it's important, each one's important because it's going to be useful later on. Okay? And if you always have to do the quadratic formula, it's just time consuming. Okay, so real quick I want to jump back to the formula. Okay? This is the solution to every single problem. Right? No matter what your equation looks like, this is the solution. So this formula can tell you a lot, right? And it can tell you, the plus or minus tells you how many roots there are, right? Because it splits into two parts. A negative b plus the square root, blah, blah, blah. Then a negative b minus the square root, blah, blah, blah. Like there's two answers here. We also got different answers in our equations, right? Like number 1, we got real roots. But in number 2, we got imaginary, right? So what part of the equation tells us that? Well, that would be the square root, okay? The square root determines what kind of root we will have. If underneath the square root is positive, then we should have a real root. If underneath the square root is negative, then it should be imaginary. Okay, so the discriminant is the part underneath the square root, so the b squared minus 4ac. If that number under the square root is positive, you're going to have two real roots. Okay, but here, this is interesting. We have a double real root on the next one, so the discriminant is 0. Well, think about what that means. That means you have negative b plus or minus the square root of 0 all over 2. So that's just negative b plus 0 over 2 and negative b minus 0 over 2. Well, those are the same thing. That's just negative b over 2. So notice that's just one answer. Okay, because the two solutions ended up being equal. So the discriminant, the part underneath the square root, is 0. So think about that. Taking the square root of 0, you end up with one answer. But if you have it more than 0, then you have the square root of 5, and so then you get like two answers. If it's negative, the discriminant's negative, then you're going to have two imaginary roots. Okay? Conjugate, right? Remember that's, it would be a plus bi and a minus bi, right? And we can write that as a plus or minus bi. So that's what they mean by conjugate. Okay? So that's how we can tell how many roots there are. If there's more than 0, if the discriminant's bigger than 0 or less than 0, we know it's two roots. All right? We know it's imaginary when it's negative. And when it equals 0, it's two of the same. Okay? How do we determine if it's rational or irrational? Well, a rational number is numbers like 4 and 3.5 and 6/5. Things like that. Okay? Negative 300. Those are all rational numbers. Irrational numbers would be like pi and the square root of 3 and the square root of 7. Okay? Or 2 square roots of 7. Right? Something that you can't write nicely as a fraction. Okay? So, determine whether it's rational or irrational. If the number is a perfect, so here, this is where you have the square root of 3, but over here, we would put the square root of 16, because the square root of 16 is just 4, so that would be rational. So here, this is underneath the square root. It's rational when it's a perfect square. Is a perfect square, and this is when it's not. Okay, so again, I'm going to do some examples with you. All right, let's make a little more sense with it. Oops, sorry. So here, let's do number 3. So the discriminant is just b squared minus 4ac. So in this case, it would be 1 squared minus 4 times 3 times negative 1. So 1 plus 12, so it would be 13. So the discriminant is 13. Think about that, what that would mean for your answer. It would be negative b plus or minus the square root of 13 over 2a. Well, that's two different answers because it's plus or minus, so I know I have two answers. And it's the square root of a positive number, but that's not a nice number, right? I don't get a nice number out of that. So it is 2 irrational real roots. Okay? Let's do another one. So again, b squared minus 4ac. So we have negative 5 squared minus 4 times 1 times negative 14. So 25 plus 56 equals 81. So the discriminant is 81. All right, now think about your answer. If you were actually doing the quadratic formula, it would look like this. Well, the square root of 81 isn't 0, so I know I'm going to have two roots. And since the square root of 81 is a nice number, then I know this is going to simplify. I would not leave that there unless that radical had to stay, and it doesn't. So I'm going to have two rational real roots. Okay? All right, let's do a couple more. Feel free to try these on your own. So here we have 5 squared minus 4 times negative 3 times negative 4. So 25 minus, let's see, what do we get? Where's my pen? Oh, goodness. Okay, 48. All right, minus, we get negative 23. So the discriminant is negative 23, just that number. Now, think about your roots. if I were to actually solve this, okay, I know it would look something like this. Well, that's not 0, so I've got 2 roots. Well, that square root's not going to go away because square root of 23 is not pretty, but also it's negative, so I'm going to have imaginary. All right. Here we go again. All right. So b squared minus 4ac, negative 10 squared minus 4ac. So here we have 100 minus 100 equals 0. The discriminant is 0. So think about what your answer would be. This is plus or minus nothing. Adding 0 and subtracting 0 do nothing. So this simplifies to just negative b over 2a, which is just one answer. And since it's one answer, and look at that, that's a fraction, okay, a and b are not going to be anything gross. So I'm going to have one rational real answer. Okay? Hopefully that makes sense. If not, please come talk to me in class.